Let's talk about the method of U-substitution, do some practice, and talk a little strategy. First, we pick some function in the integrand to be u. Then we compute the differential du, which is the derivative of u, and then dx. Once we have u and du, we rewrite the integral in terms of u and du, and all the x's should cancel if we picked the right u. Once we have our integrand rewritten in terms of u and du, we integrate with respect to u, which gives us a function in terms of u. Finally, we substitute back the original u to get the complete answer. Let's take a look at the first one, the integral of x to the fourth over the square root of x to the fifth plus 2 with respect to x. So let's first try to see if part of this looks like the derivative of another part. Well, I see we have x to the fifth plus 2 in the denominator, and if you differentiate this, you get 5x to the fourth, and we have x to the fourth in the numerator. So let's try u equals x to the fifth plus 2. Then the differential du is 5x to the fourth dx, and if I solve that for dx, I get 1 over 5x to the fourth du equals dx. All right, so we have our u and our du. Let's substitute those into the original equation, or original integral rather, and hope it gets easier. So here's that integral again, but I've made the substitutions for u and for dx. Some powers of x cancel, and after pulling out a 1/5, the integral simplifies down to the square root of the integrand simplifies down to the square root of u, which is convenient to rewrite as u to the 1/2. The better to use the power rule for integration. Here's the integral in terms of u. I did just using the power rule, and the final step is to plug the original equation back in for u. So our answer will be 1/5. So in for u, we'll plug x to the fifth plus 2, and that's raised to the 1/2 plus 1, so to the 3 over 2 power. That's divided by 3 over 2, and we have plus an arbitrary constant on the end. All right, next let's take the integral of e to the 1 plus natural log of x over x dx. And now I know you could simplify this with some algebra, but I want to do it this way to demonstrate the chain rule. So let's try u equals 1 plus natural log of x. So then we compute the differential du. This will be 1 over x dx, or if we solve for dx, that dx is x du. Next we substitute into the original integral. Then some of these x's cancel, and we're left with the integral of e to the u du, which is simply e to the u plus an arbitrary constant. Plugging the original function back in for u, this gives us the final answer of e to the 1 plus natural log of x plus c. But I do want to check our solution. Let's check that we have found a correct antiderivative by differentiating. So if we did this right, we should get e to the 1 plus natural log of x over x, since that was our original integrand. All right, so let's take this derivative using the chain rule. We'll get e to the 1 plus natural log of x times the derivative of the inside function. All right, and what's the derivative of 1 plus natural log of x? This would be 0 plus 1 over x. So this is e to the 1 plus natural log of x times 1 over x, which is indeed the original function. One nice thing about integrating is that it's easy to check the solution by differentiating. Finally, let's take the integral of 5 over the quantity 3x plus 7 with respect to x. So this time, let's let u equal the function in the denominator 3x plus 7. Then we compute the differential, du. That's going to be u prime dx, so du equals just 3 dx. Solving for dx, we get dx equals 1 over 3 du. Now let's substitute back into our original integral. This turns into the integral of 5 over u, and I'll replace dx with 1 over 3 du. Now there's no cancellation this time, but there are some constants that I can pull out of the integrand. This is the same as 5 over 3 times the integral of 1 over u du, or 5 over 3 times the integral of u to the negative 1 du. So the power rule for integrating does not work when the exponent is equal to negative 1. So recall that the integral of x to the negative 1 dx is the natural log of the absolute value of x plus c not x to the 0 over 0, which would be undefined. Okay, so this integral is 5 over 3 natural log of the absolute value of u plus c. And the final step is to substitute back in the original function, which was 3x plus 7.